Thank you, Lilian. Thank you, Enrique, for giving me the opportunity of showing what we at University of Cantabria has been developing in the last years regarding tropical cyclones forecasting. So it's clear that tropical cyclones are impacting Africa. There are physical impacts regarding wind, rainfall, waves, storm surge levels, but also flooding. But it's not also the hazard, but also the socioeconomical impacts, such as casualties, destruction of infrastructures, economical damages. As an example, in these pictures, you can see the effects of tropical cyclone Chaido last December, with a lot of damages in infrastructures and casualties. So the forecasting of tropical cyclones, the wind, the waves, the surge, the rainfall, the flooding is needed for an efficient early warning system. Besides, the track and intensity of a tropical cyclone is uncertain, so it is needed to do an ensemble of plausible tracks to forecast probabilistically the effects at the coast. So here you see an example of this envelope of the possibilities of wind intensity of TC Chaido hitting Mozambique. So the point is that what is needed is to address, not in a deterministic way, but in a probabilistic way, obtaining, for instance, the probability of intensity of the landfall point. Like in this sketch, you see that the larger probability of a plausible tropical cyclone is larger for category 3, but there are possibilities also that the tropical cyclone can have category 5. So regarding waves and storm surge levels, the traditional methods for the computation of these variables are too heavy computationally. So here you see an example of a project in which we have been involved for obtaining the waves and the storm surge due to tropical cyclones in the Vanuatu archipelago. And as you see, all these small triangles are the grid of a numerical model at about 40 million of nodes. So one simulation of a tropical cyclone for waves and storm surge requires running in almost 200 computers during 10 hours. So this is very heavy from a computational perspective. So in order to simplify that, what we propose is a hybrid probabilistic approach, fast, and also trying to allow an estimation of uncertainty. So the requirements of an early warning system must be fast. We aim to use the system with low computational resources, just in one desktop computer. We want to use open source tools for waves, surge, tide, rainfall, wind, flooding, impacts, but we also want to be probabilistic, running a number of simulations based on, as you are going to see later, on the Joint Typhoon Warning Center tracks. And this is done by means of the combination of hybrid, surrogate, or meta models. So basically, a meta model, you see here on the right-hand side, is based on data mining techniques for selecting plausible hypothetical cases, a library of pre-run cases that we do at our university, and based on these databases and the data mining, we are able of doing the hybrid reconstruction. So on the left-hand side, you see an schematics of one of the systems for storm surge levels that we have developed. In the middle panel, you see the wave footprint associated to a tropical cyclone, and on the right-hand side, you see a zooming of the waves. Every pixel is every 100 meters, spatial resolution, high resolution. So the point is that once you have a tropical cyclone, like this historical tropical cyclone Ivan in 2012, that was hitting Samoa, what we are going to obtain from the system is the spatial and temporal evolution of the wave field at the regional scale, but without the necessity of running the model. And on the right hand side, what you see is that based on another model, that we are able of doing zooming. The color represents the value of the wave height, the arrow represents the direction of the waves. So our experience in research. Here you see some snapshots or recent papers in which we have shown to the scientific community different models for waves, the tropical cyclone-induced waves. These are these two papers, or a model for downscaling waves to nearshore areas, or on the right-hand side, an efficient model for predicting storm surge models. All of them are meta models and are relocatable to different areas. Our experience in terms of research projects for modeling tropical cyclone-induced waves and storm surge, we have been lucky of working in different projects in the Pacific, in North Pacific, South Pacific, but also in the North Atlantic. So just as an example, we are collaborating with the University of Sydney, doing estimations of tropical cyclone-induced waves and storm surge levels in the Great Barrier Reef. We did a collaboration with CSIRO, a research center in Australia, for obtaining flooding maps in Vanuatu due to tropical cyclones, but we have also worked in the Republic of Marshall Islands, in Guam, in Hawaii, and recently we have started a project with Duke University for modeling the effects of hurricanes hitting North Carolina. Our experience in terms of consultancy projects. This is a milestone in what we have done in the last years, and it was a 2-year project funded by World Bank and managed by Pacific Community, SPC, in Fiji. This was a project that we did in collaboration with NIWA, and the purpose was to develop tools for the Tonga and Samoa meteorological services for impact-based forecast. Here in the schematics you see that some of the products that we developed, and I'm going to show you some of the I'm going to show you now an example of how the system works. So first, we download the tracks from the Joint Typhoon Warning Center when we have a warning of a tropical cyclone. So these tracks represents the evolution, the forecast for the following 72 hours or 1 week of different research institutes. So based on these tracks, we apply our methods, and in a question of minutes, we are able of obtaining the tropical cyclone-induced storm surge levels. Step 3, we calculate the waves at regional scale, again, in a question of minutes at a regional scale, but also step 4 at a local scale. So based on that, for instance, we can estimate the probabilistic forecast of having a wave height larger than 8 meters. And if we focus in a specific point, we can do the forecast of total water levels, and as you see here is the summation of the effects of storm surge levels and astronomical tide in order to obtain the total water level that is a proxy and indicator of flooding. So the system that we have created can be relocatable to different areas. The ecosystem that we use is based on Python, Jupyter, notebooks, books, and this is snapshots of some of the applications that we have developed, PDFs, HTML file. but it's not also Jupyter Notebook, but also dashboards to visualize the results. So here you are having a look, and this was in collaboration with Niwa, the dashboard for visualizing the operational system for the short-term forecast. Here we are showing in Tonga Tapu, the main island of Tonga, the waves hitting in one particular instant, and here you see the different components of the sea state in one particular instant. But also, we developed also a seasonal forecast of tropical cyclone activity. So the idea here was to provide a tool for forecasting for the next 1 month or 6 months in the tropical cyclone season, the probability of having a tropical cyclone or even having a tropical cyclone larger than a particular category 3, for instance. So it's not just only the hazard, but during the project we were able of using exposure layers. Here you see an example of the infrastructures of roads or details of the land uses. So apply some damage functions. We were able of obtaining the damages, the impacts due to rainfall, wind, coastal flooding, and this is an example of TC Gita hitting the main island of Tonga Tapu. This is another snapshot of another example, and this is Apia, the capital of Samoa, in which on the left-hand side you see the coastal flooding map, and on the right-hand side you see the damages. The system that we developed here was a GIS easy-to-use system for allowing to zoom in particular areas. So during the project, we were able of seeing the early warning system that they have developed in Samoa, and this is an example of the screenshots that they have in Apia. So an important piece of the system that we developed was the local engagement, the capacity building, and also the knowledge transfer to the local meteorological services. As you see here, this is an example of the training that we did in Apia to the Samoa Meteorological Service, or we were also in Tonga Tapu. We create a kind of leaflets for visualizing easily the different dynamics. I think that's it. Thank you for your attention, and hope we can collaborate in this project.